So we are going to focus on this advanced math handout today. We're going to cover questions that the SAT considers advanced and also questions that just stump a lot of students. So even if they're not necessarily classified as the hardest by the SAT, they're going to be questions that students often struggle with. So there's going to be a mix of questions today. Some of them we really need to drill in the concepts and do the questions the long way. There are no shortcuts for some of these questions. And then other ones we can really simplify and make way easier than we would have maybe thought before today. So there is a little chat box so you guys can ask me questions during this workshop. I set aside about 3 hours for this today. I'm hoping that it won't take 3 hours to get through. I'm going to aim for just over 2 hours, but if we need to do a Q&A at the end, or we find that it's just taking a little longer to get through some of these questions, we'll take that extra time. So before we get started today, does anyone have questions about the format of this workshop today before we go in and dive into these questions? So for those of you who don't already know me, my name is Carla, and I have been doing SAT and ACT prep for the last decade. So that means I've worked with pretty much thousands of students and spent a large portion of my adult life looking at SAT and ACT questions with different kinds of people. So some students are really great at reading and other ones are really great at math. And then finding ways to make these questions easier for all kinds of students. So what we're going to do today is go through these questions bit by bit. For those of you that were in my grammar workshop yesterday, I had a couple of students submit feedback that they really enjoyed being the part that we did, where I asked questions and then I gave you a little pause and you could work through those questions on your own, and then we looked at them together. So for today, for most of this, I am planning on structuring it that way. Could you guys just comment if that is yes, you want to work through the questions, so we'll have you do a page and then we'll look at those questions together, or would you rather have me do them all together from the get-go? So far, 2 people, Bella and Caroline, are speaking for everyone, and Chris also says sounds good. Okay, so you should, in the email that I had sent, also have the key to the core concepts and critical thinking skills. I'm not going to go through this in detail today. If you've never taken that workshop with me, I have one next Wednesday at the same time as this one today, where I will go through each of these concepts in detail. For today, I just wanted you guys to have this handy because every now and then we may reference back to a concept in here, but the purpose of today is not for me to walk you through this. It's just so that you have this handy and that you can see how many of these questions you actually need to use these concepts for. So someone asked here, before the day off. Oh, I can send out the materials a little earlier. Would you guys prefer that if I sent out the materials not the day off, but a few days early so you can start working through it? Yes, no, maybe. Okay. So for the advanced math, for the SAT worksheet, our first couple of pages here will be no calculator. So that means the SAT will not allow you to use a calculator on these questions. Some of these questions that we're going to go over today, if you're also taking the ACT, they're good to know for the ACT. But as you already know, on the ACT, you can use the calculator for the entire math section. After we look through these no calculator questions, we're also going to look at calculator questions. So there's a little bit of an SAT trap for students who think that just because you can use a calculator, you should use a calculator, and that's not necessarily true. So for most of these calculator questions, we're actually not even gonna use a calculator at all. So this page, we're not gonna use a calculator. This next page, we could use a calculator on one of these questions to make it easier. This next page, we could use a calculator just on one of these questions from practice test 6. On this page, we don't really need a calculator for any of these problems from test 9. And then for the test 10 questions, we could really benefit from knowing how to use our graphing calculator on a couple of these questions. So I just want to set the groundwork, lay the groundwork right from the get-go that you may not necessarily even want to use your graphing calculator on all of them. So for today, we're going to start with these 4 questions. So test 1, number 15 and 19, and then test 2, number 11 and 13. And I'm going to give you guys, let's say, 5 minutes to work through these. They would probably take you a little bit longer on test day than 5 minutes. So if you find that the 5 minutes isn't enough time for you to get through all of them, at least just write down a little note of what you think you should do for each problem, how you would approach it. So just think through it that way. And that way, when we go over them together, you'll at least know if my approach matches what you would have done if you had time to work through it. So these questions, Patrick, are in the advanced math handout. And that is, I'm posting this link here. It was sent out in an email to you guys earlier today. And I think it's actually in your Google Drive folder too, possibly. Oh, the number, so just to orient everyone, the way this is structured is each question number is the actual question number from the practice test. So if you see here, and you guys can see my screen, right? If you see question number 15, that's the actual question number 15 from the no calculator section in practice test 1. Same for question number 19. So these questions are all pulled from actual practice tests. They were not created by me. These are all property of the College Board. Okay, so now that we have that sorted, I'm gonna set a timer just for 5 minutes. And then I'm gonna check back in with you guys when the 5 minutes are done. Okay, let's look at these. So for these questions, let's do a quick little vote here. Which one do you think would be the most time consuming on this page? Number 15, 19, 11, or 13? Which one do you think would take the most time on test day to work through? So Caroline voted number 11, and I agree with Caroline and Bella, who both voted for 11. 11, just using the conjugate on the no calculator section to simplify that will chew up the most of your time. So remember, for the entire SAT math question, you are going to get the exact same point for number 11 as number 19. And number 19 takes a fraction of the time that number 11 would take us to complete. So let's work through these one by one. So for test one, number 15, I see a couple of clues before I dive in. My first clue that just jumps out at me is I see some constant values. So I see an A and a B here, and then I see a C over here. And then they give me A plus B equals 8, and they want to know the two possible values for C. So whenever I see the first clue that they are having me solve for a constant, like C, and my second clue is there's an equal sign right here. So clue 2 is the equal sign. Another clue would be if you see the word equivalent. Sometimes they give you the two sides of the equation, but they don't actually tell you it's an equation. They just say, this is equivalent to that, and you have to do the work of actually setting the two things equal. So I have those two clues. So my first step here will be to make the sides match. And you're going to see me do this several times today. This is my little trick to make these kinds of questions just way, way easier. So what I mean by make the sides match is that I'm either going to multiply out the left-hand side of the equation. So I'm going to go ax times bx, ax times 7, or I could factor the right side of the equation. I don't know about you, but for me, factoring something that has a C in it or a constant just doesn't sound like a lot of fun. So instead, I'm just going to expand the left-hand side of the equation. And it's going to give me something like abx squared plus 7ax plus 2bx plus 14. And I now know that this is my left-hand side of the equation, right? And it is equal to this right-hand side of the equation. It is equal to that. Now that I have that, I can zoom in, and we're going to be doing this a lot today too. We're going to zoom in on just the parts that we need. So I'm looking for C, and C is a coefficient of X, right? So I am looking just for this little part. And that is going to be my middle term on the left-hand side too. They give us that A plus B is 8 right here. So A plus B equals 8. And I can, over here, see that A times B would equal 15 because the two sides of the equation are equal. So I know that ABX squared has to equal 15x squared. So AB equals 15. So then I can think what two numbers multiply together to give me 15 and add together to give me 8. That would be A equals 3 or 5 and B equals 5 or 3. It doesn't really matter which way we do it. We could solve it both ways if necessary, but in this case, it won't be. So I can plug in here for 7ax plus 2bx equals cx, my A equals 3 and my B equals 5. So I'm going to say 7 times 3x plus 2 times 5x equals cx. And you'll note here that each term contains x, so I can just cancel those out. And I would have, whoops, I would have here that 21 plus 10 equals C, so 31 equals C. So that's going to be D has a 31. If we swap those and we used 5 for A and 3 for B, we would get the 41 for C. If you guys have any questions as we move through these problems, just type them in the little webinar chat box so that I know to go back and explain something a little bit more. If I don't have any questions, I'm going to assume that I'm just explaining it perfectly and everybody gets it, okay? So number 19, we have another couple of clues. So our first one is it says in a right triangle. So when a question on the SAT or ACT tells you in a right triangle, you see that little phrase, and they don't already give you a right triangle, you basically want to draw one. That's like telling you, please draw a right triangle. If you don't draw the right triangle, it's going to be a little bit of a harder problem. So they say in a right triangle, one angle measures X degrees. So I'm just going to pick a corner of my triangle and call that X. Doesn't matter which one I pick. And it says sine of X is 4/5. Remember SOHCAHTOA? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So since we're dealing with the sine part here, I could say sine of X is the opposite is 4 over the hypotenuse is 5. And then they ask us, what is cosine of 90 minus X? So if you have been studying the math part of the core concepts handout, you would already know this just without even drawing a right triangle and just having that memorized. On the second page here, I have a little tidbit of info. The sine and cosine of complementary angles are equal. And the way that the SAT tells you, hey, these angles are complementary, remember, they always kind of talk in code. They're not going to tell you, you have complementary angles or draw a triangle. They're going to give you other clues and you need to know what to do in those situations. So they're telling you that you have a complementary angle going on here by giving you that 90 minus X, this little part right down there is what they're giving you. So when I look at this and I see the 90 minus X, if you really want to score above a 600, 700 in the SAT math section, I would want you to recognize this as a complementary angle. And the complementary angle of sine and cosine are equal. But let's say you drew a blank and that slipped from your memory during the test and you just had to come up with a way to solve for this without remembering that rule from pre-calc. So a complementary angle, 90 minus X, we have this angle right here is X, and they want to know what is 90 minus X. Well, the 90 minus X angle has to be the other angle in the triangle because we already have a 90-degree angle, right? We already have the angle that we called X. So the remaining angle has to be 90 minus X. Remember, there's 180 degrees in a triangle. So this right here is 90, and this angle here plus the angle there has to also equal 90 to give us that 180 degrees. So cosine of 90 minus X is also going to be 4/5. Remember, cosine is adjacent over hypotenuse. The angle adjacent to that is 4, and the hypotenuse is still 5. So we would get cosine of 90 minus X is 4/5. You'll note if you take a lot of SAT practice tests that if you are guessing on one of the gridding questions, the best answer to guess would be the given information or the question number if you have no idea what to do. So in this case, the given information was 4/5. So if you were blindly guessing, I would just guess 4/5. The SAT has a sense of humor. So sometimes for number 20, if that is in the no calculator section, the answer will also be just 20. Or if you are on question number 18, the answer will just be 18. So that's a non-mathematical guessing strategy for you. So number 11, for this one, we are using the conjugate from the core concepts handout. So the conjugate you're going to need to use whenever you see radicals or imaginary numbers in the denominator. So you're going to take what's in the denominator and you're going to rewrite the terms, but you're going to change the sign. So here we have 8 plus 2i in the denominator. So the conjugate would be 8 minus 2i. Note we just changed the sign. We need to multiply both the numerator and the denominator by that conjugate. So we are going to take 3 minus 5i over 8 plus 2i, and we are going to multiply both that numerator and denominator by 8 minus 2i. And that's going to give us 24 minus 6i minus 40i plus negative 5i times negative 2i. And that's all over 64 minus 4i squared. Note for the denominator, I didn't need to FOIL that all out because I am using my factoring rules that are over here. If I have two factors that are the same, and one is a plus and one is a minus, I'm not going to have a middle term. And my first term is just going to be the first part of the factor squared, and my last term is just going to be the last part of the factor squared. So I have all that. The next thing I'm going to need to know here is that I squared equals negative 1. They gave us I equals the square root of negative 1. So it's really nice that it's just I squared equals negative 1. We can infer that, and it's good for you to know that too. So now we're going to simplify this to 24 minus 46i plus 10i squared all over 64 minus 4i squared. My I squareds, somebody asked a question. Yeah, you're not going to touch the numerator at all. So someone asked, you don't change the 3 minus 5i to 3 plus 5i. You would leave the numerator totally alone. You just look at the denominator to find your conjugate. So this is the only part you're going to look at for your conjugate. So once we have this, I can change my I squared to a negative 1 factor. So that's how I like to note that. So then I would have 24 minus 46i plus 10i, oops, plus 10 minus 1 all over 64 minus 4 times negative 1. And when I simplify that, I'm going to have 14 minus 46i all over 68. When I look at my answer choices, I can see, oops, none of my answer choices match, right? So I have to go a step further and reduce this fraction. So both my numerator and denominator can be divided by 2. And that's going to be 7 minus 23i all over 34. So on the SAT, usually when they give you questions with imaginary numbers, they're just going to ask you to basically combine like terms. It's pretty rare to see a question like this one specifically on the SAT no calculator section. It is possible though. Every now and then on both the SAT and the ACT, so the SAT calculator section and the ACT math section where you can use a calculator for the whole section, they will give you a question that's similar to this with imaginary numbers and let you use your calculator, which I really am still trying to wrap my mind around why they would allow that, because it's just so simple to solve this on the calculator. So if I'm going to change my sharing here, oops, to my calculator. And I'm just going to plug this question into my calculator and show you guys. Oops. Okay. So if I'm plugging it in here, I would open parentheses and then put in 3 minus 5, second I, whoops. So 3 minus 5, and then second, and the I buttons down here. Close parentheses, divided by 8 plus 2 second I. So I'm just using the I down here, press enter, and it gives me this complicated decimal, right? That doesn't match any of my answer choices. So instead of converting each of those answer choices to a decimal, I'm just gonna go math and then frac and press enter. And it's going to give it to me in the A plus BI form, which all the answer choices are in. So if you see this kind of question in a calculator section, that's what I would expect you to do. So let's go back to, oops, right here. The next question, so number 13. So there are two ways that you can solve number 13. The first way is going to be complete the square. The second way is going to be to use the quadratic formula or equation. The third way, which is, I said there's two ways, right? Because I don't really recognize the third way as a real way for this, because it says the sum of all the values of m would equal this, would be to try plugging in answers. And that I would not advise for this, because they want to know the sum of the values of m that satisfy it. So my preferred way will always be to complete the square. Maybe like one SAT math question out of 1,000, I would opt for the quadratic formula instead of completing the square. Most of the time, completing the square will just be way, way easier. So my first step to complete the square here is I need my leading coefficient to be the number 1. So you want 1 as leading coefficient. So I'm going to divide everything by 2, or you could show it as factoring out that 2. When I divide both sides by 2, that 2 just goes away. So I have m squared minus 8m plus 4 equals 0. Now I'm at the point where I can complete the square. So I'm going to move my 4 over to the right-hand side. So I'm subtracting 4 from both sides, basically, and get -4. And then I'm going to complete the square. So I'm going to take half of the middle term and square it. So half of -8 is -4. And -4 squared is going to be 16. So I'm going to add 16 here, and I'm going to add 16 here. I'm going to just make it in blue. So that's the part I actually completed the square. So the benefit of completing the square is you're going to get something that's really easy to factor because you made it a perfect square. So on the left-hand side, I just have m minus 4 squared. And on the right-hand side, I have that equal to 12. Now I can take the square root of both sides, and I get m minus 4 equals the square root of 12, plus or minus the square root of 12, right? So here's a little trick. I am not going to simplify that radical and try to pull out a 4 or do anything with it until the very end, because I usually hope that my radicals will just go away and cancel out. So I don't deal with them until the very end, and there's nothing left for me to do. Now I have m equals 4 plus or minus the square root of 12. And remember, they asked for the sum of the solutions, the sum of the values that satisfy that equation. So we're going to take 4 plus the square root of 12 and add that to 4 minus the square root of 12, because that's each of our solutions. And when they say sum, they're saying add. Here are my square roots of 12s cancel. So I basically just have 4 plus 4, which equals 8. And D will be our right answer choice there. Any questions on what we have covered so far? I have a lot of screens open on my computer, so I need to find the question box. Okay, here we go. Any questions? Okay, makes sense. Let's go on to this next page. So I'm gonna give you guys, do you want a hint of which one's gonna be the hardest on the page so you know which one is safe for last or which one to just write down your idea for? Or would you rather go into it blindly? Anybody wanna vote before I time you for the next couple of questions? Blindly, okay. Ooh, we have blindly and hint. Yeah, more of you need to jump in so I know if there's a hint or not. Okay, so if this were me, I would save number 13. So I would save this one for last. However, I recently had a student that I was tutoring one-on-one a couple weeks ago before quarantine, social distancing took place. And he solved this question in his head. So that's a challenge for you guys before I start the timer, that this actually takes a little bit of time for number 13, but it is possible to solve it just by looking at it. So with your hands basically behind your back, not even putting your pencil on the paper, and solve it by looking at it and know 100% that you got it right. So that's going to be your little challenge for that one. I'm going to start a timer for 5 minutes, and then I'll check back in with you guys when the timer's done. Okay, let's look at these questions. So for number 19, so I told you guys before that out of these, number 13 would be the one that I would say for last, but it's also one that it is possible to solve just by looking at it. I've also had students solve number 19 just by looking at it. How many of you are in pre-calc right now or have taken pre-calc or trig? Has anyone taken it yet? You can just write yes in the chat if you have. So if you recently took pre-calc or trig, then you may remember your unit circle. And when you look at the point, square root of 3, comma 1, you think, oh, that is pi over 6. So A just has to be 6 and you're done. So that's fine if that just popped out at you. But sometimes we're a little rusty, right? Or you guys can hear me, right? I think there's like, yeah, obviously you can hear me because you responded to the question. I had something pop up on my screen that said, unmute yourself. And I thought, well, I thought I'm unmuted already. Okay, so we need a strategy for if the pre-calc rule from the unit circle just slips our minds and we look at this and we have to work our way through, right? So the first thing I note is they give us angle AOB is pi over a radians. They want angle A. They gave me these coordinates. And I like making triangles inside of circles on the SAT because they are really helpful. Most helpful triangle inside of a circle would be if we made an isosceles triangle. We're not going to use it for this question, but it's just good to know that we like isosceles triangles inside circles because each radius would be a side of the triangle. So it would make it isosceles, and then these base angles would be the same, right? But that's not what we're going to use here. We may use that later today. Instead, we're going to zoom in just on this part and draw. Let me change my pen color so it's a little clearer. I'm going to draw a line down like that, make that a right angle. Because my x distance is square root of 3, I can say that this right here is square root of 3. And I can say that the height of the triangle, or the y distance, is 1. Then I can use my Pythagorean theorem, which they give you at the beginning of every single math section on the SAT. C squared equals a squared plus b squared. So c squared equals 1 squared plus square root of 3 squared. So c squared equals 1 plus 3. So c squared equals 4. C equals 2. So now we know our hypotenuse up here is 2. And they asked for the measure of this angle right in here, right? AOB. So I could say that sine theta equals 1 over 2, or opposite over hypotenuse. Now, if I don't have my unit circle memorized, which honestly at the moment I don't, I have not tutored pre-calc a little bit of time. I'm a little rusty. Every now and then I memorize it, and then it leaves my brain. But that doesn't matter because I have the trig table memorized. I can set this up at any time and get all my values for the unit circle really quickly. So when you're setting up the trig table, you're going to draw all the angles for the first quadrant of the unit circle. So you're going to have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then we're going to put sine first. I think of sine as selfish, so sine gets to go first. A lot of students correct me and say that in SOHCAHTOA, sine goes first. Whichever way works better for you to remember, just use that. So sine theta and then cosine theta. And then I'm going to count up to 4 starting with 0. That's why you need to know that sine goes first. So I'm going to go 0, 1, 2, 3, 4. And then I'm going to count down from 4 for the cosine theta. So I'm going to go 4, 3, 2, 1, 0. I'm going to square root everything. And then very lastly, I am going to divide everything by 2. So if this was a real SAT question, obviously I wouldn't need to do it for every single angle. I could just stop once I get to the part that I need. So I need to know what is theta when sine theta equals a half, right? That's what I had. And sine theta would equal 30 degrees. So if you don't have it memorized that 30 degrees is pi over 6, they give you at the beginning of every single math section that 2 pi radians equals 360 degrees. So that means that pi radians equals 180 degrees if you just take half of the numerator and half of the denominator. So I can say 30 degrees times pi over 180 degrees, divide both sides by 30, and that would give me 6 in the denominator, and I have pi over 6. And they asked for a, right, which is our denominator, so our final answer is just 6. Moving on to number 20. So I'm going to move this over here. And this trig table is on the core concepts on the back page, right over here. We have the trig table. For the next question here, in the system of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of a over b? So you are pretty much guaranteed to see a question just like this one at least once when you take the SAT. Some students get 3 or 4 questions on an SAT that all test them just on this concept, which is kind of crazy to think of. So on the very back page of the core concepts handout, I have this little bit. When you see the words no solution on the SAT, I want you to immediately think that you have parallel lines that will never intersect, because remember, an intersection is a solution. So you have parallel lines that will never intersect. So the 2 lines have the same slope, but different y-intercepts. If you have infinitely many solutions, that means it's one line right on top of another line. So you're going to have the same slope once again, and you're going to have the same y-intercept. Usually the y-intercept doesn't really matter that much for these kinds of questions. I really don't know why. I'm still waiting for the question where the y-intercept would actually matter, but it generally just does not. So if I see they want to know what is a over b, I can see up here that both of these equations are in standard form, right? And a and b would be what gives me my slope. I see here that they have infinitely many solutions, so I know they have same slope and same y-intercept. And since I just want a over b, and that's the part of the equation that forms the slope, I'm just going to ignore my y-intercept over here because that's not what they're asking me for. And now when I zoom in, it becomes really apparent that a is going to be 2 and b is going to be 8, because remember, they have the same slope. So I can say that a over b equals 2 over 8 equals 1/4. And 1/4 is my final answer here. Moving on to number 13. So now again, I hope you guys recognized it when you did this question. We have another one of those make the sides match types of questions. Let's see all our clues. So our first clue is an equal sign. That's a pretty obvious clue, right? Our second clue is a is a constant, and they want to know a. So we have 2 sides of an equation that are equal to each other, and we're looking for a constant. That means we want to make the sides match. So I'm first going to show you the longer way to figure this out, and then I will show you how to figure it out just by looking at it if you want to try that out. Was anyone able to figure this out just by looking at it? I'm curious. You can just type yes if you could just look at it and figure it out, or you think you did. I have not given the answer yet. Anybody? You can also tape no if it's a negative. That way I know you're still listening. Yeah, I scratched my head too the first time the student solved it just by looking at it. But that same student solves all of these SAT math questions, probably like 95% of them, just by looking at them. So I have him physically show me his logic behind each answer choice, because I think it's just crazy to be able to solve these just by looking at them. Okay, so the longer way of solving this, when we're making the two sides match, I am not going to divide my left-hand side of the equation because there's a constant in the denominator, and that's kind of icky. I don't want to divide by a, what's going to happen there? So I am immediately drawn to the right-hand side of the equation, and I'm going to put this negative 8x minus 3 over a denominator of 1. And then I'm going to find a common denominator because my left-hand side of the equation, everything is under the same denominator. So I'm going to take negative 8x minus 3 over 1, and then I'm going to multiply the numerator by ax minus 2 and the denominator by ax minus 2. Where did I get that from? Well, this denominator was ax minus 2 and that one. So I just want everything under the same denominator so I can start ignoring it and not even dealing with it. So when I multiply that out, I'm going to get negative 8ax squared plus 16x minus 3ax. And then, let's see, negative 8ax, or yep, minus 3ax. Did I do that right? I'm having like a moment here right now. Negative 8ax squared plus 16x. I'm going to redo this. Negative 8ax squared plus 16x minus, yeah, I did that right, plus 6. Just had to think that through for a second. It's hard when I can't hear anything. I'm just talking to myself the whole time, basically. Okay, and then I'm going to bring down this up here, this negative 53, just to be complete. And then I'm going to put that all over one denominator, ax minus 2. Now, after I've made the sides match, I can just zoom in on the part that I need. So I can see here that negative 8ax squared would have to be equal to 24x squared. So I can say that 24x squared equals negative 8ax squared. Cancel my x squareds on both sides. Divide both sides by negative 8. Oops, negative 8ax squared. Let me put that in. So then I would get negative 3 equals a. I could have also zoomed in on a different part of this. So I could say that 16x minus 3ax is equal to 25x. Always just make sure that you account for each part on each side of the equal sign. So it doesn't really matter which part you pick, just pick a part that has the constant and then set the two sides equal. So now let's see, what would we have done if we wanted to solve this just by looking at it? I'm just going to clear up all the clutter. So if I'm just looking at it and I don't want my pencil to hit the paper, which I really think is not the best advice, I would look over here and I would think 24x squared plus 25x minus 47 divided by ax minus 2 equals negative 8x minus 3 minus 53 over ax minus 2. That means that 20, so this is something you would do in your head, but I'm going to do it on paper to make it easier to see, that 24x squared divided by ax would equal negative 8x. So 24 divided by what number gives us negative 8? It would be divided by negative 3. So that's if you're just thinking through this in your head. Pretty crazy, right? I think that's pretty crazy. So we're just probably not going to be thinking of that on test day. But if you're running out of time and this is the very last question that you get on your SAT and the proctor calls 30 seconds and you don't have time to go through this whole process, at least look at it and just reason. Think, okay, this side's divided by that. What number could that possibly be? Okay, number 20. So I love questions like this on SAT math sections because usually when they give you a ton of words in a word problem, you don't really need all of them. You just need to figure out which parts do you need. So the first thing I see here is angle B is 90 degrees. So I have a right triangle. So I'm probably going to have to do what when I see angle B is 90 degrees? Anybody know? What will I have to do the moment I see that 90 degrees to make this a lot easier? Draw it. Yeah, we're going to have to draw it. Then they give us that BC equals 16, AC equals 20. Triangle DEF is similar. So the moment I read that a triangle, another one is similar, I basically stop paying attention for the most part, especially when I have a right triangle. So similar right triangles have the same respective trigonometric ratios. That means I can ignore basically all of that. Doesn't matter, okay? So right down here, when they say what is sine of F? Sine of F would equal sine of C. Make it a little more clear. So I don't really have to deal with sine of F. So right here, I'm going to draw my triangle. And I'm going to label it as A, B, C. And I'm going to put my hypotenuse as 20, BC as 16. And then right here, I would really encourage you to memorize the 3, 4, 5 triangle ratio because I can see both 16 and 20 are divisible by 4, right? That would give me a 4 and a 5. So over here, this would be 3, and 3 times 4 equals 12. So my side AB equals 12. You could also solve for this 12 by using the Pythagorean theorem. Either one works, but just knowing the 3, 4, 5 ratio will really, really help you. So now I know that sine of C, so this angle, right, looking at C, is just going to be the opposite over the hypotenuse, or 12 over 20. So that's going to be 6 over 10, or 3 over 5. And that is my final answer. And I didn't have to spend the time to figure out what is 1/3 of those lengths. I could just use triangle ABC and be done with it. Okay, moving on to this last little bit. So this is going to be the last no calculator questions. These really shouldn't take you a ton of time. There's only one out of these three that's a little bit of time. So I'm still going to give you 5 minutes. Use it wisely. And then we'll move on to the calculator section. So I'm going to give you 5 minutes once again. And starting now. Okay, let's look at these questions. So just a quick little poll from you guys. Which one of these did you find the most challenging? 13, or not 13, 15, 11, 10, or 19? 15, 11, 10, or 19? We have a couple of people who have responded. Most of you have not. I hope the rest of you are still there. You're not off making coffee or doing something other than some advanced math for the SAT. Okay, so we're actually going to use the same principle that we would for number 15 as we would for number 10. So these two questions use the same principle. And that can be kind of tricky for students. And I actually sometimes see when I'm looking at a student's QAS report from the actual test day for the SAT, that they will miss this concept with one question and then answer it correctly with another one and not quite see that it's basically the same concept. It's easy to start getting intimidated when you see the x cubed in number 10 from test 9. So let's look at number 15 first. So this is, again, basically a guaranteed question type on the SAT, where you're going to see you're solving for a constant. And here they say can be rewritten as. What do you think can be rewritten as code for? Did anyone catch that little SAT code for can be rewritten as? That is equal to. So we are going to just write it out again with an equal sign. So I'm going to say that 1/3 x squared minus 2 equals 1/3 x minus k times x plus k. Because the two sides are equal, we want them to look equal, right? So we're going to make the sides match. Once again, make the sides match. I am not going to factor out the left-hand side of the equation because that just looks really icky to me. You'll notice that usually I just expand things. So on the right-hand side, I can rewrite that as 1/3 x squared minus k squared. And the number one mistake I see students make on this is they don't distribute this 1/3 to both terms. So if you notice, oh yeah, I need to make the two sides match, and you multiply that out correctly, it's really common to forget to distribute that 1/3. So be careful not to do that. So we're gonna have 1/3 x squared minus 1/3 k squared. Now we're at the point where we can bring this down and have 1/3 x squared minus 2. Note how I have 1/3 x squared on both sides. So that just basically cancels out. I can subtract 1/3 x squared from both sides and not even worry about it. And then I have -2 equals -1/3 k squared. I'm solving for k. So I'm just going to divide both sides by -1 or multiply both sides by -1 to get rid of that. And then I get 2 equals 1/3 k squared. I'm going to clear that fraction by multiplying everything by 3. That's what those big brackets mean. So I have 3 times 2 is 6, and 3 times 1/3 is just 1. So I have 6 equals k squared. I take the square root of both sides, and then I have the square root of 6 equals k. So D is going to be my answer for number 15. Number 11. So this is kind of one of those surprising SAT questions. You are more likely to see this on an ACT than on an SAT for this kind of concept. However, note that the SAT likes to borrow from the ACT and the ACT likes to borrow from the SAT sometimes. So if you have extra time on your hands to work through practice tests, even if you're planning on taking the SAT later this year, it's not a bad thought to work through an ACT practice test, 1 or 2 also, and just see, what are they doing over there? Because every now and then they do borrow from each other. So which of the following could be the equation of the graph above? we need to look at how many terms do we have in this polynomial, or we can look at these roots. So roots are our x-intercepts, where the graph touches or crosses the x-intercept. So whenever we have a even power, so it's raised to an even power, it's going to touch the x-axis. So right here, we have just x, right? It just touches it at 0, so we would have x equals 0 as one of these factors. And because it just touches, we need that x raised to an even power. So I need this x squared. So I can immediately eliminate A and C. And I eliminate answer choices as I work through these problems instead of just trying to find the right one, so that I don't accidentally pick something that was obviously wrong. So I know that x has to be an even power, and they don't really even test us on knowing that these are odd powers. This is 1. They could have been mean and given us the same terms in the factors, and then just tested us on knowing should it be an even or an odd exponent. But they only tested us with the even or odd with the x equals 0 factor. So now, since x crosses, our x-intercept here is -3, we know that we're going to have the opposite sign for the factor. So this is a factor of x plus 3. And over here, we again flip that sign. This is going to have a factor of x minus 2. So I am looking for an x minus 2. So I'm going to cross out that, and I'm going to cross out that. And the only one I have left is b. And I double check that x plus 3 term also to make sure that matches my factor, right? So that one works. Number 10. So once again, they are asking us to solve for constants. And this whole handout, if you are struggling through some of these questions, I highly recommend doing this handout until you can answer these questions without struggling. You may think, well, I've already seen these questions once. I'm going to remember how to solve them. I find that practice and reinforcement really benefits students, even if they've seen these questions before, because you will see questions just like it on test day. And having that repetition and getting really comfortable with making things match and just picking out parts and setting them equal, growing comfortable with that will benefit you so much when you're under pressure and it's actually the day that you're taking the SAT. And for these kinds of questions, so the make them match questions, you're going to see them way more on the SAT than the ACT. So just keep that in mind too. But remember, the two can borrow from each other. So if you're taking the ACT, maybe later this year, they'll borrow this kind of question. So they want to know what is the value of AB here, right? And there's a lot going on. And the SAT is a time test. So I would not multiply out everything on the left-hand side to perfectly make it match the right-hand side. That's just going to be a lot of work. You could do that. It's not wrong to do that, but it's kind of time intensive. So I'm just going to pick out parts in order to solve for A and B one at a time. So if I want to figure out what is A, right? I could see that AX times 5x squared would give me 5ax cubed. And that's going to be the only term when I'm multiplying out the left-hand side that would give me an x cubed. So I can set that equal to this 20x cubed. My x cubes cancel, and I get 5a equals 20. So a equals 4. I'm done solving for a after I do that. Now I'm going to do the same for b. So I'm going to just pick, I'm going to pick this x term as for you. I'm going to use the -2x to solve for my b. So I'm going to look at the left-hand side and see what do I need to multiply together to get all my x terms. So I can see here, I am going to have that ax, let me just erase that part, ax times 4, right? That's going to give me one x term. And I'm going to have the 3 times negative bx. So I'm going to have 4ax minus 3bx equals negative 2x. I can plug in 4 for a, so that's going to be 16x minus 3bx equals negative 2x. My x's all cancel out, and I get 16 minus 3b equals negative 2. I'm going to subtract 16 from both sides, so I'm going to get negative 3b equals negative 18, so b equals 6, and ab equals 4 times 6, so that equals 24, which is C. So that's what my work would actually look like on test day. You could totally multiply everything out on the left-hand side so you can clearly see it, but if you're really doing the amount of practice that you should be doing, if you want a great SAT score, you will get to the point where you feel comfortable doing this. For number 19, so this was an actual SAT question, I believe October 2018. I'm 90-ish% sure that it was October 2019, that this was the actual question that students saw on their test on that day. And I had quite a few students come to me that year that missed this on their test, and they solved it using substitution or elimination, and then they made a silly mistake somewhere along the way and got it wrong. So there's a clue here. Our first clue is we're in the no calculator section. No calculator. Our second clue is they are asking us for a combo of variables, both x and y. They are not simply just asking us for x or y by themselves. So whenever they're asking for like 2x minus 3y, 5x plus 5y, the very first thing I'm going to do is see if I can simply add those equations or subtract one equation from the other one without doing anything to them. So I would draw a line here. I'm going to add them, and then I would get 5x plus 5y equals 2,500. Okay. I have seen this method work a lot on SAT questions. If it doesn't work the first try, so I am adding them together, I'm subtracting one from the other one, I would prefer most of the time to use elimination over using substitution for the no calculator section of the SAT. So that means in real life, if I'm working with a student just on algebra homework, I would say, oh, let's use substitution. That is my preference. I love substitution. But on the SAT, for most system of equations questions, you're going to be way more accurate using elimination, simply adding the two equations or subtracting one equation from the other one, which is what we did here. Moving on to the next questions. Does anyone need a break, or are you fine with the pace to just keep on going? So you can either say fine or break in the chat. If I see a bunch of I need a break, I'll give a break. If everybody's fine, we'll just keep going. Only one person so far needs a break. She's getting outvoted. So if anyone else also needs a break, speak up. I will be uploading this to YouTube probably tomorrow or the day after at the latest. So if some of the stuff is just starting to go in one ear, out the other, you're having a hard time retaining it all, don't worry, you can rewatch it at a later date. I will also be emailing out the answer key with all the worked out solutions to each question that we're going through today, so you can really look at it again at your own pace. So today's just meant for practice and so that you can get live answers to your questions as we go through them. So I am going to set the timer again for 5 minutes. But honestly, I'm actually not going to give you 5 minutes for these questions. I'm going to give you 3 minutes because 5 minutes is a little much for these ones. Okay, so 3 minutes, and then I'm going to circle back, and we're going to look at question 29, 26, and 28 from this first calculator page. And I will give you a hint that you do not need your calculator for any of these questions, 29, 26, or 28. And if you're using your calculator, you're probably wasting time. So it doesn't mean you can't use it, but it's just going to be a time waste on these questions. And if you know me personally, or you've worked with me one-on-one, you'll know that I love the graphing calculator. It's pretty much one of my favorite possessions. So if I'm telling you, don't waste your time using the calculator on these questions, it's really to your benefit not to. So let me set a timer here for 3 minutes, and then we'll look at those questions. Oops, that was a little loud. Okay, let's look at these. So for number 29 here, they want to know which of the following must be true about P of X if P of 3 is -2. So is basically just an equal sign. So we could say P of 3 equals -2. So this actually is going to be the remainder theorem, which is pretty popular on the SAT for more advanced math questions. So for the remainder theorem, if P of 3 equals -2, all we know about that then would be that x minus 3, so if we're plugging in 3 here, that means we're testing out the factor x minus 3. That would mean x minus 3 is not a factor, and the remainder is -2 if we divide P of x by x minus 3. So D would be the answer here. So that's kind of a mouthful. I'm going to show you how the remainder theorem also comes into play with a different SAT question. So I'm going to look at a question that's not on here. It's from practice test 2. And it's going to be, I think, it's in the no calculator section of practice test 2. Aha, okay. So here's another question where we could use the remainder theorem. So it says the expression 5x minus 2 is equivalent to which of the following? So this is from practice test number 2, if you want to look this question up later. So the first week we could do this is just by using long division, dividing 5x minus 2 by x plus 3. But that's kind of time consuming, especially if you have really long polynomials and it's in a no calculator section. Synthetic division would be the next best thing, right? It can be a little simpler to use synthetic division. But when we're using the remainder theorem, we would say the numerator here is f of x, and x plus 3 would become x plus 3 equals 0, so x equals negative 3. And we would plug in this negative 3 for our x. So this x would be negative 3, and then we would see what f of x is equal to. If f of x equals 0, that would tell us that x plus 3 is a factor, or 5x minus 2 is divisible by x plus 3. When I plug in the negative 3 for x here, I actually get it equal to negative 17. So that means my remainder is negative 17 when I divide 5x minus 2 by x plus 3. When I look at these answer choices, only one here, answer choice D, has a remainder of negative 17. So you can see here, if you have really long polynomials, that's going to be way easier to just use the remainder theorem. But for this particular question, they are just straight up testing you on, do you know the definition of the remainder theorem? That's going to be a little rare for the SAT, but I have this question in here because it's important for you guys to know the remainder theorem. Let's look at number 28 here. So in the XY plane, do any of you know what we're supposed to do when we read in the XY plane? What are we supposed to do? If I read in the XY plane, what is that SAT code for? Does anybody know? Anybody know? In the XY plane, what does that mean? What are you supposed to do when you see in the XY plane? You're supposed to draw the graph. But in this case, we already have a graph drawn for us, right? So we would think that it's already done, but it's not. So let's read a little bit further. Oh, I'm going to change my pen color here too. So it says ABCD is a square and point E is the center of the square. The coordinates of point C and E are 7, 2, and 1, 0, respectively. So a lot of students will start labeling that and really getting into the nitty-gritty of this question, but that's way too much work. And remember, we want to be fast. We want to do the least amount of work to get the right answer. This very last bit here, which of the following is an equation of the line that passes through points B and D, is really all that matters for this question. So if they want the equation of the line that passes through points B and D, that little word at the beginning in the XY plane was a clue that we need to draw that line. So I'm going to connect point B here to point D. And that's the equation that I want to find. So for any equation of a line, you want to look for the slope and the y-intercept. So here I can see my slope is negative. When I look at the answer choices, all of those have negative slopes, so that's not that useful. But I can also see that my y-intercept is going to be between 2 and 4. And if you are not really good at drawing straight lines and you think of, well, I'm going to need to be really precise if I'm going to do it the way she just did it, you can bend your test booklet and use it as a ruler, or you can even use your Scantron page and use that as a ruler. So draw the best line that you can with that. So we can see we need a positive y-intercept that's between 2 and 4. It can't be a negative 1 y-intercept, that's too small. Can't be a negative 1 y-intercept on here, again, too small. Positive 4 is too big, so it's going to have to be b. And when I multiply this out, I get negative 3x plus 3, and yes, that works. 3 would be between 2 and 4. What are they actually thinking you're going to do here? They want you to go and plot these points. So let's see, where's C and E? So they want you to plot those points, find that slope, find the perpendicular slope, then use y minus y1 equals m times x minus x1, and find the equation of the line. That's way too much work. If you feel comfortable with just drawing the line, looking for the y-intercept, you're going to save so much time on these questions. So somebody asked, Chris asked, if I could repeat the definition of the remainder theorem. So you can write here that if P of 3 equals negative 2, x minus 3 is not a factor, and the remainder is negative 2 when you divide P of x by x minus 3. If it was equal to 0, then it would have been a factor. Let's go on to question number 26 here. So they say the complete graph of the function f is shown in the xy plane above, which of the following are equal to 1. So f of negative 4, f of 3 halves, f of 3. So f of negative 4 is the same as saying, what is y equal to when x equals some value? So 4, for instance. So if I have f of x, that equals y, right? Or some value of x. So f of negative 4, what is y when x is negative 4? So I'm going to count negative 1, negative 2, negative 3, negative 4. My y would be equal to 1. So y equals 1. I can check 3 over 2. So 3 over 2 is just 1.5. So that's going to be here. And that y is also going to be equal to 1. And when x equals 3, so we have 1, 2, 3, that y is also equal to 1. So it is 1, 2, and 3 for those. Does anybody have questions on the problems we have covered so far before we move on to the next page? Any questions? Nope, none so far. So I am going to give you guys, let's see. I'm going to give you 5 minutes for this next page. You can use part of the 5 minutes as a mini break. If you're able to complete these questions in fewer than 5 minutes, it's totally possible. I will tell you that for one of them, you can use an app in your calculator. It's not really an app. I call it an app called Numeric Solver. So if you're familiar with Numeric Solver, I will be going over it when I go over these questions too. For one of them, you could use Numeric Solver. And for most of, I think like 3 out of 4 here are really not that bad. So again, there's only one doozy of a question on this page, and it's not really even that much of a doozy. And it may not be the question that you think just by looking at it. So most students, when they look at this page, they immediately see number 30 right here, and they see this equation, and they're like, uh-oh, this is going to be really bad. And this question is probably the easiest on this page. So let's have you guys dive in. I'm going to give you 5 minutes, and then we're going to look at these questions. Good luck. Okay, let's look at these questions. So number 30, the first question on this page, usually tricks students that have the highest level in math. So if you've already taken pre-calc or you're in calculus already, you are likely to overcomplicate this more so than a student that has never seen a polynomial to the third degree. So they say the function x cubed minus x squared minus x minus 11 over 4 is graphed in the xy plane above. So remember, so xy plane, that means you want to draw. If you already have a graph drawn the way they have here, don't get fooled into thinking that it means you don't have to do anything. It's still a clue that you're going to want to put your pencil on the paper and draw on that graph. If k is a constant such that the equation f of x equals k has three real solutions. Okay, f of x equals k, is that going, whoops, does my screen still show the timer? Let me share my screen. Thanks for letting me know. I'm gonna re-share it. Probably got frozen on there. Oops. There we go. So if they say f of x equals k, is that going to be a vertical line or a horizontal line? Does anybody know what kind of line that would be? The f of x equals k right here. Is that going to be a vertical line like so, or is it going to be a horizontal line? Going to be a horizontal line, right? So I would draw a little horizontal line above it immediately. The moment I think, ooh, that's a horizontal line, I would write it there so that I don't forget it later on. So it says it has three real solutions. What does this three real solutions mean in terms of graphs? What are solutions? Does anybody know? Anybody feel comfortable translating those words to math? Three real solutions. I have one answer out there. Yeah, so it's the line crossing the graph. So that's where, oops, let me put it like so. That's going to be where the lines or the graphs slash lines intersect. So our x-intercepts code for that would be zeros or just x-intercepts or x comma 0. So the three real solutions are not going to be x-intercepts here. It's just going to be where two lines intersect. So we need to figure out where could we draw our horizontal line on this graph. So let's draw our horizontal line and have it intersect that graph, the existing little squiggly line, that polynomial, 3 times. So I'm going to take this and I'm going to move it around. And I can see, let's test out each of these answer choices actually. At +2, it only intersects that graph 1 time, so it can't be that. At 0, it only intersects it once. At -2, only once. Ooh, at -3, we have 1, 2, 3 solutions. So it's going to be D, okay, as our answer here. Notice that this did not even really matter, okay? We didn't need it. So just because they give you something a little complicated doesn't mean we're going to need to actually use every piece of information that they give us. So for number 32, a lot of words, right, going on here. I would zoom in on the equation first and think about what kind of equation is this? Is this a circle? Is it a quadratic, or is it just a line? Who knows what kind of equation this is? X plus 220 over 2. So big step for all of these questions is just knowing what concept are they testing you on. So if they give you an equation, it's helpful to think of what kind of equation is that? So P equals X plus 220 over 2. What kind of equation is that? Is that linear? quadratic or a circle? What do you guys think? Linear, quadratic, or a circle? Hey, God, no guesses from you guys. Yeah, linear, great. So it's going to be y equals mx plus b in that form. It's linear. There's no exponent, so it's not going to be quadratic. It's not a circle or a parabola. Well, parabola is the same as a quadratic. So it's just linear, y equals mx plus b, but it doesn't look like y equals mx plus b, and that's kind of the confusing bit. So I would rewrite that given equation as y equals a half x plus 1/10, dividing each of those terms by 2 so that it actually looks like a y equals mx plus b. And then when I read that, I never really read long word problems. Maybe don't repeat that I said that. I don't really read them. I just read the very last sentence, and then I see what do I actually need to go look at in the beginning, if anything, to figure out the problem. A lot of the time, just by reading the very last sentence, you find that you already have everything you need. So it says, according to the model, for every increase of 1 year in age, by how many millimeters of mercury will the normal systolic blood pressure for an adult male increase? So we have this key word here, increase. So whenever you see increase, decrease, change, what are we thinking of for increase, decrease, change? In terms of y equals mx plus b, is that going to be our slope or our y-intercept? It's going to be our slope. Great. So we just want to know our m. So our answer here is just 1/2. And then we're done. So you could answer this question just by looking at it too, without even really putting your pencil on paper. So number 34, this is the question that you could use equation solver for on your calculator. So it says, in a study of bat migration habits, 240 male bats and 160 female bats have been tagged. If 100 more female bats are tagged, how many more male bats must be tagged so that 3/5 of the total number of bats in the study are male? Whoa, that's a mouthful, right? So we need to organize our information so that we can keep track of everything. So I'm going to say that male over the total equals 3/5. And then I'm going to figure out what is my total number of bats and what is my number of male bats. So let's go find all my male bats first. So we have 240 male bats plus how many more male bats? So I'm just going to call this how many more x. So I have 240 plus x male bats. That 240 plus x will also be part of my total. And now I'm going to go find my female bats. So I have 160 female bats plus 100 more female bats. So I'm going to have 160 plus 100. So that would give me 3/5 equals 240 plus x over 500 plus x. I would cross multiply and then get 1500 plus 3x equals 1200 plus 5x. I would combine like terms, divide, so I would get 300 equals 2x, divide both sides by 2, and x equals 150. Once you are at this point right here, you could also use your calculator. So if you have the TI-84 plus CE, you could go like so. Let me share my calculator screen here. The new screen share. Share and share. Let's see here. Okay, so I would go in the calculator to math, and then I would go up 1 to numeric solver, press enter. And then I would put in the first box the left-hand side of the equation. So I would put in 1500 plus 3x. And then in the bottom box, I would put the right-hand side of the equation. So 1200 plus 5x. And then to solve it, I would press the graph key, so to hit OK. And then to solve it, I would press the graph key again, and it gives me x equals 150. So this will solve any linear equation for you. It could also solve quadratics, but I would not really ever use it for a quadratic because equation solver can only give you one answer. So with quadratics, we often have more than one answer, right? We're gonna have a positive and a negative or two different x-intercepts, and this will only give you that one answer. So I would generally not use it for a quadratic or for an equation containing a square root unless you're in a bind and you have to. Okay, let's get back to the next question here. Yeah, we're on number 35. So the dynamic pressure Q, so again, there's a lot going on here, right? Let's skip to the end and see what they want to ask us. So they say, what is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid? So I know I need faster over slower. So when I go back up in that paragraph and I read it, I can immediately be on the lookout for faster and slower. So the dynamic pressure Q generated by fluid moving with velocity v can be found using the formula above, where n is the constant density of the fluid. An aeronautical engineer uses the formula to find the dynamic pressure of a fluid moving with a velocity of v, and the same fluid moving with the velocity of 1.5 v. So this v is going to be my slower, and 1.5 v is going to be my faster. Now we have to be really careful when we plug in our v and our 1.5 v, because I see students make a really silly mistake here all the time. So I'm going to put as my faster 1/2 n, and we're going to be careful here. We're going to put the 1.5 v inside of parentheses. Using parentheses will be critical for these equations. Always use parentheses and make sure you put everything inside of them. So the most common mistake here would be just to put 1.5 n 1.5 v squared. So to put it just like this and not square that 1.5. That will not give you the right answer. So here in the denominator, we're just going to leave it alone for the slower because it's just a v. So 1/2 n v squared. Our n's are going to cancel, and our halves are going to cancel, and our v squareds are going to cancel. So we are just left with 1.5 squared, which is 2.25 as our answer for number 35. Any questions before we move on? Any questions at all? Okay, so again, I'm going to give you 5 minutes for this next page. We don't really have that much left. We have this page, and then this next page that has only one real tricky question on it, and then one final page, and we're done. So we are over halfway there. Okay, so for this next page, I am going to set a timer for 5 minutes, and then I'm going to check back in with you. Just real quickly, if you can tell me in the chat if the 5 minutes has been enough time or if it's been too much time for you guys. Because I can decrease that to like 3 minutes if you have been feeling that the 5 minutes you have time left over. It's enough? Okay, so I'm just going to leave it as 5 minutes. So we are going to set it as 5, and then you can get started. Okay, let's look at these. So for number 25, the first thing I'm going to notice with a question like this, do you guys, by the way, see my screen okay? I just want to make sure because the last time I switched over from my timer to just the test. Okay, great. So the first thing I'm going to notice for this question is that they give me a table, right? We have a table there. And whenever we are given a table on the SAT, they want you to look for the X and Y intercepts. They don't tell you, hey, go look for the X and Y intercepts. They give you a table and they expect you to go look for them. So I'm immediately going to see when X is 0, Y is -2, and that is going to be my y-intercept, right? So for this question, they want to know what is the value of f of 3, and they say it's a linear function f. So linear function f is going to be y equals mx plus b. We already know our b is going to be -2. So I can rewrite that as y equals mx plus b, y equals mx minus 2 for the b. And I can plug in another part of that table to solve for my x and y. So let's say we are plugging in 2 and 4. I could say that 4, oops, the bad 4 equals m times 2 minus 2. So 6 equals 2m. So 3 equals m. I could also solve for the slope by taking this as 2 comma 4 and this as 6 comma 16 and actually using the slope equation, rise over run, change in y over change in x. Either way works. So now I know my slope and my y-intercept. So I can just write my y equals mx plus b. Let me move this over as y equals 3x minus 2. And they want to know what is f of 3, which is the same as asking you, what is y equal to when x equals 3? So y equals 3 times 3. I'm just plugging in the 3 for x, minus 2. So y equals 9 minus 2, y equals 7. So 7 is our answer there. For number 30 up here, they say the scatter plot below shows the amount of electric energy over a 10-year period. Which of the following models the data in the scatter plot? So all of these equations are quadratics, right? Or parabolas. And you should know your 3 forms of a parabola. I can't speak anymore. Are going to be your vertex form, your y-intercept form, and your x-intercept form. In this case, they gave us these parabolas in the y-intercept form. When we connect the dots over here, we can see that this is an upside down parabola, right? So it's an unhappy parabola or a parabola with a negative leading coefficient. So I need a minus in the front here, a negative sign. So it can't be A or C. And I can also see here that I have a positive y-intercept. So I'm looking for a positive here. So it can't be B. So my answer here would be D. And then for number 27, so you could do this question 2 ways. The first way that I'm going to show you is just how to do it without really using your calculator. And then after we go through that way, I'm going to show you how to solve this in your calculator. So without your calculator, I would complete the square. And when you look at the core concepts page, you can see the circle equation right here is x minus h squared plus y minus k squared equals r squared. And we want to manipulate the given information into an equation that clearly shows us our center of the circle and that radius because they are asking us for the radius. So remember, to complete the square, my first step would be to divide everything by 2 so that I can get my x squared coefficient to just be 1. So that would give me x squared minus 3x plus y squared plus y equals 22.5. Now I'm going to complete the square twice. I need to complete the square for the x's, and I need to complete the square for the y's. So I am going to rewrite this but I'm going to leave a blank space so I can complete the square for each one. Y squared plus y and a blank all equals 22.5. So let's go complete the square here. So I'm going to take half of this -3 and square it. So it's going to be 3 over 2 and then 3 over 2 squared. You can do that part in your calculator. So this would be 3 over 2 squared. So that's going to give me 2.25. And whenever you complete the square, you're going to end up adding. You're never subtracting when you're completing the square. Then for our y's, I'm going to take half of 1, and I'm also going to square that. And that's going to give me 0.25. So over here, I need to add the 2.25 and the 0.25. Because we're looking for the radius, and remember that x minus h squared plus y minus k squared equals r squared, I can at this point pretty much just zoom in on this side of the equation because that side equals r squared. So if I add 2.25 and 0.25 to 22.5, this would give me 25. So I know that 25 equals r squared. So r equals 5. So that can be a little bit math intensive for students who are not comfortable with completing the square. You do need to know how to do this though without your calculator for if you happen to get this kind of question in the no calculator section. Let's say this was in the calculator section, not no calculator. I am going to show you how to use the Connix app. So I'm just going to switch the screens that I'm sharing and share it from here. Okay. So I'm going to turn on my calculator, second quit out of that, go to apps, and then I'm going to go down to the Connix app. Press enter. I'm going to choose the first option, which is circles. Press enter. I do not need to put it in the x minus h squared plus y minus k squared. I can use the second option here, which is the form that the circle equation was given. So I'm going to press enter. And now I'm just going to put in the coefficients. So my x squared coefficient here was 2. My y, let's see, yeah, x squared and y squared coefficient was 2. My b is going to be -6. That's going to be the x coefficient. My c is going to be my y coefficient, which is 2. And then my d is going to be -45. So you have to be careful here. The equation that they give you is equal to 0. The equation that they gave you in this question was not equal to 0. So you have to move that 45 over to the left-hand side. So we're subtracting it from both sides. Now we're going to press graph. And to move around on the circle, you can't just use these arrow buttons right away. You first have to press the trace button. Now I can see that the maximum x distance on this side is 6.5. I'm going to use my cursor. I'm going to press to the right. Kind of goes counterclockwise on this. And then I can see my minimum x distance is going to be -3.5. And the distance from +6.5 to -3.5 would be 10. So our diameter is 10 and our radius is 3.5. So let's go back. Any questions on that at all? Let's see here. Oh, I'm moving the cursor by pressing trace first at the top of the calculator. That's how I move the cursor. If you don't press trace first, the cursor won't move. It's kind of sneaky. And if you are in an Algebra 2 class, you may want to explore that app a little bit further because they do other conics too, like horizontal parabolas and things you may not see on the SAT, but that you would see in a math class. So we looked at all of these. So we have 2 pages left to go. So we're going to do 24, 30, 31, and 36. I'm going to give you 5 minutes for this page. We'll look at it together. Then we'll only have one more page to look at, and then we'll be done. Or how about this? Would you guys rather have me just give you 10 minutes and then you finish up all the questions and then we look at them? Say yes or no. 5 minutes or 10 minutes? Yeah, so I'm just going to give you 10 minutes. You can finish up all the questions. So you're going to do 24, 30, 31, 36, 25, 30, 35, 36, all of them. And then we'll look at them together and wrap up for today. Thank you for sticking with me for so long. This is a lot of math that we're going through. I hope that you're learning some new things though, and it's helping you stay engaged and not burn out yet. Okay, so I'm going to set a timer for 10 minutes. Whoops, nope. That's really loud, at least for me. So 10 minutes starting now. Okay, let's hop back in here. So for question number 24, this is going to be the exact same thing that we've seen a lot of today, which is make the sides match. But you'll note that the SAT tests you on this concept, which is really critical thinking at its finest in different ways. It's not always going to be the exact same way, even though your strategy will be the same regardless of how it's asked. So they say both of these so f of x equals 5x squared minus 3, and f of x plus a equals 5x squared plus 30x plus 42. What is the value of a? So a here is a constant, right? Which is a clue for make them match. So since we know what f of x plus a equals, I am going to plug x plus a in over here. And I'm going to get f of x plus a also equals 5 times x plus a squared minus 3. I just plugged in the x plus a here for the x squared. And that's going to be the same for that x. That simplifies to 5 times x squared plus 2xa plus a squared minus 3. And that simplifies to 5x squared plus 10xa plus 5a squared minus 3. And I can take what's up here, this 5x squared plus 3x plus 42, and set it equal to what I just found, because that is also equal to f of x plus a, right? And I just found what is f of x plus a. So I can say 5x squared plus 30x plus 42 has to equal what I just found. Now I'm going to do the same thing that I did before. I'm going to zoom in on the parts that I need in order to solve for this. So I can say that 30x has to equal 10xa. So 30x equals 10xa. My x's cancel and I have 30 equals 10a. Divide both sides by 10 and I get 3 equals a. I could have picked a different part to set equal. I could have said that 5a squared minus 3 equals 42. So I would have gotten 42 equals 5a squared minus 3, 45 equals 5a squared, 9 equals oops, does a weird thing sometimes, this pen. 9 equals a squared, and 3 equals a. So it doesn't really matter which part you pick to make the two sides match. You just need to make sure that you account for all the parts on each side of the equal sign. Number 30, let me just make this smaller so it doesn't overlap as much with number 30. So over here, we are given a graph. Whenever we get any graph, we're going to be looking at the slope and our y-intercept. Just get in that habit. The moment you see a graph, you're thinking about the slope and the y-intercept. And they ask us, which of the following could be an equation of the line of best fit? And we can see up here that this is just a straight line, right? So this is y equals mx plus b. And all of the answer choices are in y equals mx plus b form. So we know we're on the right track. So we are going to see up here that we have a positive slope, but we also have a problem. All of these answer choices have positive slopes. So that's not going to help us much. So next, I'm going to extend this line to see where it crosses the y-axis. But whenever you look for the y-intercept, make sure that the x is actually 0 there, which in this case it's not. Our x is 10. So I actually need to extend this line. Whoops, I'm going to extend this line, and I'm going to extend my x-axis. So this would be 8, 6, 4, 2, 0. So my my y-intercept would actually be way over here, which would be below this 300, right? I don't need to find the exact y-intercept, but I know it has to be less than 300. So my y-intercept of 402 would be too big. My y-intercept of 300 would be too big, but my y-intercept of 84 is perfect. So D is my answer here. For number 31, actually, before I move on to number 31, just so you know, the alternate method for this ice cream sales problem would be to find the slope. So we would find the slope, and then we would use y minus y1 equals m times x minus x1 to actually solve for the equation of the line. But that takes a lot longer than just extending that line. Number 31. So in the xy plane above, the circle has center hk and a radius of 10. What is the value of k? So it says it has a radius of 10. So I want to draw that radius. I am going to draw a line here and here. Easiest radii to draw would be the radii with the given points, right? So I'd say R1 equals 10, R2 equals 10. And they want to know what is the value of k. So I am going to draw the height of the triangle right here and figure out what is that height. I also am given this information that this is x equal to 4 and this is x equal to 20. So my whole base of the triangle would be the distance from 4 to 20, or 16. I can take half of that for each triangle here. So I can say this is 8 and this is 8. So really, I'm just dealing with one, oops, let me draw that a little bit better. Triangle that looks like so, has a hypotenuse of 10, a base of 8, and I want to find the height because that's going to give me my k, which you can tell, let me just change this, the k is going to be my y value, right? So that's going to be my height of the triangle. So I can say c squared equals a squared plus b squared. So 10 squared equals 8 squared plus b squared. So b equals 6. And that is my answer here. I could also see this, let's see, a 3, 4, 5 triangle once again. So I can divide 8 by 4, and that would give me, no, I would divide 8 by 2, and that would give me 4, sorry. And then 10 by 2 gives me 5. So this is 3 times 2, which is 6, if you're just using the 3, 4, 5 triangle to unlock that problem. For number 36, our first clue here is no solutions, right? So that means we have the same slope and different y-intercepts. Both of these lines and equations are given to us in the ax plus by equals c form. Since they just want a over b, that's going to be our slope. So I can ignore my y-intercepts here. And now it becomes clear that a is going to be 3 over 4, and b is going to be 1/2. And I'm going to have a over b equals 3/4 over 1/2. In the calculator, you can plug that right in, and you would get 3 over 2, or 1.5 as your answer here. Either answer would be credited. Moving on to number 25. We'll actually circle back to it in a second because both 25 and 36 we're going to do in the graphing calculator. So 35. In the equation above, a and b are constants if the equation has infinitely many solutions. So that means we have the same line. So it's going to be the same slope and the same y-intercept. And I can see up here that this looks an awful lot like y equals mx plus b. And I'm going to do the same thing that I did before. I'm going to make the sides match. So I'm going to have, either I can factor out that 4 over here, Or I can distribute this A, and you may have guessed it right. I'm just going to distribute that A. So I'm going to get AX plus AB equals 4X plus 10. I am going to zoom in on one part at a time. So they want the value of B, right? So I'm going to start with A because I can say that AX equals 4X. So A is just 4. So 4X plus 4B equals 4X plus 10. And now I can say that 4B equals 10. So B equals 10 over 4 or 5 over 2, okay? Do you also want me to solve that the other way, or is this way sufficient? Because I can show you by factoring 2, or we can just leave it as is. You can put in the chat if you also want to see it by factoring, or if this is good enough, just seeing it this way. I'll check the chats in a second. Let's see here. Okay. For number 30, they say in quadrilateral ABCD, AB, sorry, is parallel. It doesn't print well here. AB is parallel to BC and CD equals half AB. What is the measure of angle B? On the SAT, when you get shapes that are not regular rectangles, squares, triangles, circles, you want to break up those shapes into the more familiar shapes. So my very first step here would be to draw a straight line down. They gave us this little right angle here. That right angle is a clue to me that I'm probably going to use some trig. So they say CD equals half AB. So I'm going to call AB just AB. And I'm going to call CD half AB. And then this would also be half AB. And they want to know the angle up here, angle B. So I'm going to call this part of angle B just theta. So I'm going to say that cosine theta equals adjacent, so half AB over AB. My AB's cancel. Then I'm going to have cosine theta equals a half. So theta equals cosine to the -1 of 1/2. Make sure your calculator is in degrees before you plug this into your calculator. Then you would get theta equals 60 degrees. And we have to add that to the right angle up here in order to get the whole angle B. So we would have angle B equals 60 degrees plus 90 degrees, which is equal to 150 degrees. Now let's look at question number 25 and 36. So for 36, it says in the XY plane, remember that's a clue for we're going to graph. A line that has the equation y equals c, this is going to be a horizontal line. For some constant c intersects a parabola at exactly 1 point. If the parabola has the equation y equals -x² plus 5x, so that's going to be an parabola opening down. What is the value of c? So if we have a horizontal line intersecting the parabola that opens down only one time, it's going to intersect that parabola at the vertex. So in our calculator, we're going to find what is the vertex of that parabola. So to do that, I am going to switch my screen share here to a different screen. Let's see here. So I have this. I do not need that to show. Let me try this again. Okay. So I have my screen here. I'm going to turn it on. So we're doing the parabola question. So we're first, let me just snooze this too. So we're first going to go to y equals, and then I'm going to put in here -x² plus 5x. And I'm going to press graph. And instead of changing the window, if it ever doesn't actually appear in the calculator screen, I would just go to Zoom, Z standard. If you ever need to change your view, that's my preference here, or zoom in or out. Then we're going to go to second trace, which is to calculate our maximum, and press enter. And it's going to ask us for the left bound. So we want to be to the left of our vertex and press enter. And then it's going to ask us for our right bound. So we want to go to the right of that vertex and press enter. And then it's going to ask us to guess. So we're going to move our cursor approximately to our vertex there and press enter. And then it's going to give us our maximum occurs when x is 2.5 and y equals 6.25. And they asked us what is c, and c was equal to y in the problem. So we would put the 6.25 as our answer. Now going back to number 25, where we were given the two equations that were both in standard form. For that question, I would go to apps and then go down to Polysmelt and press enter. Go to simultaneous equation solver, press enter. We have two equations and two unknowns. I usually have this in decimal, normal, float, degree. Then to press next, we're going to press graph. And I'm just going to enter the coefficients of each equation. So I'm going to put in 2.4, enter, move over, negative 1.5 equals 0.3, and then 1.6 over 0.5 equals negative 1.3. And then to solve it, I'm going to press the graph button. And then that gives me x equals negative 0.5 and y equals negative 1. And they asked for the x value. So that's the value I would put for that question. So let's see here. So that pretty much wraps it up for the questions that I wanted to go over today. Do you guys have any questions for me before I sign off for today? Any questions at all? Now's your chance if you have questions about anything that I went over. No questions. Oh, someone asked earlier if I could factor the question that we did, so I can do that quickly. As always, I'm going to give you a link to my website. I'm going to put that in the chat in a second. If you can put on there what you found most helpful from today or any improvements you would make in the future, I really appreciate feedback so much. I will be emailing out a copy of this video today to you guys, as well as the solutions in a PDF form. Let me just get the course evaluation here. I'm going to move myself over. And then let me put this in here. Where is the chat? Here's the chat. So this is the link to fill out a course evaluation from today. I'm just going to factor this one question really quickly, and that will basically finish it up for today. If you don't already follow me on Instagram, I'd love to see you guys on there. All of these videos go on YouTube. I also do additional videos that I do not do in workshop format because it's just easier to just record it and put it on there. Okay, so for question number, where's that one? Oh, so factoring for number 35, we would take a times x plus b equals 4x plus 10. And then I would factor out that 4. So I get 4 times x plus what times 4 gives me 10? That would be 10 over 4, right? because 4 times 10 over 4, the 4s would cancel, would be equal to a times x plus b. And now I can see that my b equals 10 over 4. So b equals 5 over 2. I have also seen students, when they factor this, instead of saying x plus 10 over 4, they would say 4 times x plus 2.5, just thinking 2.5 times 4 would give them 10. So either way there really works. So that pretty much wraps it up for today. I don't see any other questions. For those of you that stuck it out for almost 3 hours, thank you so much. Your SAT scores will show that you've been putting in the hard work. As always, if you have any questions, just email me, send me a message, and I'll do my best to answer it. So I'm going to sign off for today. Any questions? You're all good? Okay. Bye-bye, guys.